Hello, this is Mr. Collier, and today we're going to do a line of best fit by eye. Um, Later we're going to show how to do it on a graphing calculator, but today we're going to do it by eye. So line of best fit, or trend line, as you'll see in Microsoft Excel, is called trend line, is a straight line that best represents the data on a scatter plot. So we're going to try to make these lines today. We're using these four-step procedure right here. So we basically plot the points. The line of best fit should go through the mean point, so the mean of the x values and the mean of the y values. It should go through that point, and you try to make it so that there's an equal number of points above the line and below the line. Here's a couple other definitions. So interpolation, you've got a scatter plot and a line of best fit. Interpolation will help you estimate a value within the given data set. And extrapolation, if you want to predict what's going to happen in the future, then you can use your line of best fit to make a prediction. That's called extrapolation. Alright, so we're going to do this now with some data. We've got a shopkeeper notes the noon temperature and the number of gloves sales made that day. So the temperature is 20 degrees, 0 gloves. As the temperature goes down, it seems to be that the number of gloves sold goes up. So I'm going to plot this data here now. So I'm going to plot this as x and y, and I got 0, 20 to 16 and so forth. So I'm just going to plot out. So I've got the plots pointed now. So what we're going to do next is we're going to find the mean temperature and the mean number of gloves sold. So we're going to find the means here and put them on our table. Alright, so the means here, they're going to have x mean and the y mean. So I'm going to calculate the means on my calculator. I'm going to do, first of all, the x. I'm just going to add them all up and divide by however many there are. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data values. So I'm just going to add these together here. Okay, so I've added up the x values. I'm going to divide by 12. We get 9.83 for the x mean here. So 9.83. So x bar is 9.83. And then we're going to do the same thing for the y values here. Okay, and then divide by 12. Let's see that again. Oops. Okay, so there's my y mean. It is also 9.83. So I'm going to plot the mean right now, which is 9.83 and 9.83. So 9.83 is about there, 9.83 is about there. So I'm going to draw maybe an X to indicate the mean right there. Alright, and then we're going to draw a line of best fit by eye. So we're going to go through the mean point and try to get as many points above the line and below the line. And we're going to try to make sure we model the relationship as well. Make sure the line is pointing in the same direction as the points. So right now, I'm going to actually rotate this thing as soon as I figure out how to do that. Hang on. Alright, so I'm gonna get, I think this looks a bit better. This is following the line, the same direction as the point. So I'm gonna draw the line of best fit through here now. So there we go. Alright, so I'm gonna move this ruler away here. And there's a line of best fit that goes through the mean point. There's some points below the line, some points above the line, so it looks pretty good. Okay, so that's my line of best fit. What's next? Use your calculator to find the correlation coefficient and comment on your findings. So we're going to do that in a second. But first we're going to use our line of best fit to estimate these values. So we're going to use the line of best fit to estimate those. And we're going to find an equation first. We're going to do that by hand. So let's find an equation. We know that y equals mx plus b. And in this case, our y-intercept looks to be about 20. So that's going to be about 20. So b equals 20. We're going to have y equals slope times x plus 20. So there's the y-intercept, is about 20. And slope, let's find some convenient points on the line to calculate slope. By convenient points, I mean points right on your grid. So this point right here is 317. Okay, so that's 317, and I'm going to get another point that's right on a grid point. Probably this one here looks the best. Okay, so that's 12, 12.7. So that point is 12.7. So I'm going to calculate slope over here, which is y2 minus y1 out of x2 minus x1, and that's going to be well, let's do 17 minus 7 out of 3 minus 12, which equals, let me get rid of this ruler here. Alright, so that equals 10 out of negative 9, okay, or negative 10 ninths. Alright, so that's negative 10 out of 9x plus 20. So I'm going to go down to that other question now. So we have y equals negative 10 out of 9x plus 20. And the glove sales expected when it is 0 degrees. So x is your temperature, y is the glove sales. Alright, so we can use the equation to estimate the glove sales when the temperature is 0 degrees. So we just put in 0 for x and we can find that out. So negative 10 out of 9 times 0 plus 20. And this will just cancel. You just have y equals 20. So 20 gloves is what you expect to sell when it's 0 degrees Celsius. Temperature at which 14 glove sales are made, so that's going to be y equals 14. So 14 equals negative 10 out of 9 x plus 20. So we can minus 20 from both sides, and we get negative 6 equals negative 10 out of 9x. I can multiply both sides by 9. I'm going to finish this over here. I get negative 54 equals negative 10x divided by negative 10. X equals about 5.4. Okay, so when the temperature is about 5.4 degrees Celsius, or around 5 degrees Celsius, then you can expect to sell about 14 gloves. So part C, the temperature at which 30 glove sales are made. So let's do the same procedure. 30 equals negative 10 out of 9x plus 20. And we can subtract 20. 10 equals negative 10 out of 9x. Multiply both sides of the equation by 9. We get 90 equals negative 10x divided by negative 10. We get x equals negative 9 degrees Celsius. So it needs to be around negative 9 degrees Celsius before you start selling 30 gloves.